So these are the four types of quantum numbers. The first one is the principal quantum number. The second one is azimuthal quantum number. The third one is the spin quantum number. And the last is the magnetic quantum number. If you have an example of 3p4, how can you find its quantum number using these four types? Okay, let's begin. So, what do we mean by principal quantum number? The principal quantum number is the energy level of an atom. So, you can find here a simple illustration. The nucleus is at the center of the atom, and around it is the electron surrounding. And we have three energy levels: the first one, the second, and the third. Okay, so where can you find the principal quantum number? If you have an illustration of 3p4. Okay, so in the next lesson that you will have next week, so we will deal more about this. Okay, so for this we have um, three things, okay, or numbers and letters. So we have 3p4. Okay, so if you have this is the stoichiometric number, so this is the energy level. Okay, and this is the symbol for principal quantum number. Okay, so if you knew this already, so you just have to put number 3. Okay, it means that this example, it has 3 energy level. Okay, so we are done with the principal quantum number. I hope that you have understood that. Okay, next is the azimuthal quantum number, which has a symbol of letter L. Okay, so how can you get the azimuthal quantum number? So you need to remember these four letters, okay, the orbitals or the sublevels. Okay, so for azimuthal quantum number, we have letter S, letter P, letter D, and letter F. Okay, so for letter S, please remember there is no orbital. Okay, the first energy level. Okay, the letter S. Okay, but letter P, it has one orbital. Okay, but in every even though the S doesn't have orbital, but it can still occupy 2 electrons because of the energy level. Okay, so please remember that. Okay, the letter P has one orbital, so it can occupy 6 electrons. Why it can occupy 6 electrons? You will be learning that later here in magnetic quantum number. Okay, so for letter D, we have 2 orbitals. Okay, but it can occupy 10 electrons. Okay, and then letter F, orbitals, we have 3 orbitals, but it can occupy 14 electrons. Okay, so if you have familiar, or if you have memorized this one, okay, the number of orbitals by each letter in our example, you need to know what is the letter, okay, beside the number 3. Okay, so we have here letter P. Okay, so if we have an orbital that is letter P, so what is the value of letter L in this example? Okay, so if we have letter P here, and we can see here letter P has one orbital, letter P has one orbital, so you will you will have to put, okay, you will have to put 1. Okay, it means that letter L in the 3p4 has only one orbital. Okay, so we're done with the principal quantum number and then azimuthal quantum number. So let's proceed to the next one, magnetic quantum number. How will we know that this 3p4, this element, is magnetic or not? Okay, so let's proceed. M sub L. So please remember this one. In determining magnetic quantum number, you need to know this equation. Okay, it will start from negative L to positive L. Okay, it means that we will be using the number of orbitals of azimuthal quantum number. So negative L to positive L. So let's start from letter S, okay, because there is no orbital in letter S, so it will just be 0. But in every orbital, it will only occupy 2 electrons. Okay, so I will just put here 2 electrons, ayan, 1 arrow upward and then downward. Okay, so it has 2 electrons in each orbital. So it just represents by using box or boxes. Okay, next is letter P. Okay, so we have 1 orbital, so but it can occupy 6 electrons. Why? Because it says here that negative L to positive L. Okay, we will start from negative 1, okay, and then 0 and then 1. Okay, how are you going to put the electrons there? Okay, so according to the principle of you will be learning 3 principles here. Let me just check. According to the Hans rule of multiplicity, this is how you will do occupying the orbital of the electrons. Okay, so upward first, arrow upward, and then occupy the whole orbital. Okay, before going back to the first orbital, but by this time you will use the downward. Okay, downward and then downward. That's why the letter P has six electrons. Okay, 6 electrons. So the same thing, the same method that you have used in the p orbital will be given to the rest of the letter or orbitals, the letter D and letter F. Okay, so letter D, in letter D we have 2 orbitals, and it will start from negative L to positive L. So we have negative 2, negative 1, 0, 1, 2. Okay, positive 1, positive 2. Okay, so once you occupy this electron, so 1, 2, 3, 4, 5. Okay, and then go back to the first. 6, 7, 8, 9, 10. Okay, that's why it has 10 electron. Okay, and then last we have F. It has 3 orbitals. It can occupy 14 electrons. How? So negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, so arrow 1, 2, 3, 4, 5, 6, 7. Okay, 7. And then go back, 8, 9, 10, 11, 12, 13, and then 14. Okay, so 14 electron. So that's how you will get the magnetic quantum number. Okay, so let's go back to our example. So we have energy level of 3, we have a azimuthal quantum number of 1. How about the m sub l? Okay, finding the m sub l is by looking at the number of electrons above. So we have 4 electrons. Okay, so where can we find the location of these 4 electrons? Okay, so by using the 3 orbitals. Okay, so you can use this illustration. You can just put the 3 lines indicating -1, 0, and then 1, because our orbital is letter P. Okay, and then you just distribute the number of electrons on each orbital following the principle that I have given you a while ago. So arrow upward, so 1, 2, 3, 4. Okay, so you must remember the last arrow. Okay, and then uh, um, look at the number. Okay, that that the arrow has tapped. Okay, so this is the last arrow. Okay, and this is our value. So our m sub l is -1. Okay, so that's the step on how you find the magnetic quantum number. And the most easy one, the spin quantum number. If the arrow is upward, the value is positive 1/2. Okay, and then the arrow downward has a value of -1/2. Okay, so uh, for you to determine that, so you just have to look at the last electron, if it is downward or upward. But because our last arrow is downward, so we will have -1/2. So we have a quantum number um, of our example 3p4 as n is 3, l is 1, m sub l is -1, m sub s is -1/2. Okay, so I hope that you can do on your own on how to find the location of electron using these 4 types of quantum number. So that's all. Thank you very much.